Hi everybody and welcome. In today's video we are going to be taking a look at the graphs of exponential and logarithmic functions. So this is a continuation of the 4.1 lesson that we saw last week. The main difference that we're going to be looking at with today's lesson is instead of doing the calculations by hand and solving, we are going to be comparing and remembering some of those basic properties of the graphs of each of these types of functions. So this is in an effort to set up this unit with exponents and logarithms. We are going to be moving into more advanced properties than we looked at in Algebra 2. And the key for this is making sure that we have the basics solidified and well reviewed before we jump into our more advanced lessons. So after today, this will complete our review from the old stuff that we've seen before for exponential functions and logarithmic functions. And this will basically tomorrow we're going to begin our transition into some of the newer skills, the pre-calc aspect of exponential and logarithmic functions. So first thing that we're going to do is take a look at the graphs of some of these and see some of their general properties. So if we take the graph of 10 to the x power, punch it into our TI-80 series calculator or into Desmos, either one will work, we're going to see a function that pops up and looks something like this. And it goes up reasonably steeply. So that is our basic graph of 10 to the x power. One thing that we can look at, and we'll actually pop this into Desmos to explore some of these things here. Is that if we trace this function forever, and we zoom in really close as possible, we're going to see a gap between the function itself and the x-axis. So we could keep going, and we'll zoom all the way out here. We'll go really far to the left, and we're still tracing this function. We'll go all the way to like 100. And even at 100, when we keep zooming in, this is the neat thing with Desmos. Oh, we lost the ability to zoom. But basically what you would see is that there is a small gap in between the function itself and the x-axis. So if we were able to keep zooming past the Ant-Man really shrunk small level here, we would in fact see that same gap that we saw in between our function here and the x-axis. So if we went over here, maybe it'll let us do it at like 20. We'll see if we can still see that gap or not. Interesting, the limitations of our technology here. So still very advanced technology, but still not enough to show us that gap. But the point is that it is true, there is a gap between the function and the x-axis, even if we keep going forever with this graph. And that is a pretty cool thing about these functions and about basically the technology that allows us to visualize the graphs of them. So if we look at this, that is one of the properties, and we did try to show that here when we drew this in, is showing that there is just ever so slightly a small gap there. So this function will try the rest of its life as it keeps going towards negative infinity to get really close to that x-axis, but it'll never actually quite achieve that goal. It'll never actually touch that value. So one of the neat things about this for our range is that in our asymptotes, so we'll start off with that. So we have an asymptote at y is equal to 0. And I'll draw this in red ink. And again, that is because this function will never actually touch this x-axis here. So that's a limitation on what the function is able to do. It is an asymptote. It approaches it, but it never actually touches it. In the application to our range, that's going to tell us that we're going to start off at 0, and then we will go up all the way to positive infinity. We'll never actually touch 0, so that's the reason why we're going to use a parenthesis and not a bracket here. And then we never actually reach infinity, so again, one more time, that's why we're going to use a parenthesis and not a bracket here, because this function goes all the way to the moon, keeps going forever. So two quick properties of exponential functions there. The nice thing for domain is as this does go up, it does keep going to the right. So there is no limitation into how far this function goes to the right. And as you can see, this continues going forever to the left. So for domain, we have no domain restrictions, no domain limitations for exponential functions. So from negative infinity to positive infinity for exponential functions as a basic property. The next thing for intercepts, because we do not touch the x-axis, we do not have x-intercepts in this situation. So in a standard non-transformed, non-moved exponential function, we are not going to see x-intercepts. But what we will see here, if we zoom in, we do cross over the y-axis at this point. So we will see on this particular example a y-intercept at 1. The way to calculate this is we plug in x equals 0. So if we were to do that for this function, 10 to the 0 power, well, anything to the 0 power is equal to 1. So that is how we would do that by hand, calculating that that y-intercept by plugging in x is equal to 0. So that's what we have for some of the basic properties of exponential functions. Tomorrow we're going to talk about shifting them and moving them around, but just for the basics, for right now in this moment, that's what we are looking at. Second, looking at logarithmic functions. So for logarithm, just a quick reminder, if there is nothing written there as the base, I can draw a better arrow than that. It is not 1 that's hiding, it's not 2 that's hiding, it's actually a 10. So that's one of the unique things about logs, is that is a log-based 10 function right there. We don't see anything there. So logarithms look a little bit different. And again, this is something we can plug into our TI-80 series calculator. It's also something that we can hopefully find here in Desmos. We shall see. I'm not a Desmos expert, I will confess that right now. So log of x. And remember, if we don't put anything in, we're assuming that it puts in a 10 for us. It should be the same thing, and we'll even do this to prove it. Should be the same thing if Desmos is wired correctly here. If we do put in log base 10 of x, we should see these functions basically on top of each other, which we do. Yeah, so there's no difference there, and there's a good proof for you. So a couple of things for our log functions as we zoom out. We are going to see progressively our function getting higher and higher and higher and higher, albeit quite slowly. It's getting higher and higher and higher, but it does keep getting higher. So no real limitation there, just some real slow growth as we increase for that function. And the second thing that we're going to see is, again, we get really, really close here to our y-axis, but as long as we zoom in, we're always going to see, as we keep moving down on our y-axis, there is that ever so small gap. And again, keep zooming in, there is a gap between the function and the y-axis. So this one is never actually going to become 0. It's never actually going to become negative. We're going to see that it's kind of like a wall in terms of an asymptote on the y-axis. It never goes left of that wall unless we physically shift it, but in its standard, in its base form, it never actually goes beyond that wall. So a couple of quick things there for our logarithmic functions. And we can write down some of these properties here into our notes. So again, we never actually quite are going to touch this axis, but we do, as we see, get really close. I just want to show just a little bit of a gap there as we're going, and then our function is going to just kind of arc over like this to the side. So again, we do see a gap there in between the function and the y-axis. The function does keep going up forever, but it never actually goes to the side. So start off with our asymptotes. We do have a vertical asymptote this time at x is equal to 0. So that line, and we'll do this in red, the y-axis is the same thing as x is equal to 0. Never actually touches our y-axis here. So that's why we call that an asymptote. It spends the rest of its life going down and getting really close, but it never actually gets there. So in this case, we actually have a domain restriction. So we never actually get to 0. We get really close to it, but we never actually get there. So that's the reason why we have a parenthesis and not a bracket. We never actually touch 0. But the nice thing is it does go towards positive infinity. It does continue to the right forever and forever. So that's why we continue to infinity forever. For range, we have no restrictions. It goes all the way down and it goes all the way up. While it does go up really slowly, it does slowly keep increasing. So if we keep following that for infinity, it does approach positive infinity as well. And it does go all the way down. We can see that one pretty clearly on this one. It does go down pretty steeply here. So again, it goes all the way down towards negative infinity. For these ones, we never actually touch the y-axis unless it is physically shifted. So in our base form, we have no y-intercepts. but we do have an x-intercept. So if we are plugging this one in, we have the log of x. And when we're doing this, if we plug in 0 for our y value, this will allow us to solve for our x-intercept. So we can do this by just changing forms. So again, remember that is log base 10. So 10 to the 0 power equals x. Anything to the 0 power is 1. So x is equal to 1. And as we can see on our graph right here, that is our x-intercept at 1. So this one does have an x-intercept, but it doesn't have a y-intercept. Again, if we shift it, we would see that would change. But in this particular instance, we just have those x-intercepts there. So just a little bit of graphing review of some of the basics for our exponential and logarithmic functions. Again, today's goal is just to make sure before we move forward, we are solid on all of these concepts and we are ready to apply them to the next level of skills. So as always, thanks for watching. Let us know if you have any questions. And the practice questions today directly related to our graphs in these notes. So let us know if you have questions, but you're ready to start. You have all the skills